Now for a question like this where you're given some choice, it's quite often confusing. So we have two squares, and this is important to zone in on, and the side lengths are in a ratio of 3 to 2. So here's our largest square. If this is in a ratio of, if this is 3, could be anything 3 centimeters, then this one has a side length of 2. So here the ratio of side lengths is 3 to 2, and we're going to say that this is centimeters. And so for then this one, let's say this one, we're going to double the length of this, and let's say this is now 4 centimeters. Well, then the side length, since we've doubled this square, this one, if the side length is going to be the ratio of 3 to 2, then the larger square has to have side length of 6, because 6 to 4 is the same as 3 to 2. So here our ratio is 6 to 4, but remember that reduces to 3 to 2. Now let's take a look at another example, and let's say now we want to triple the original, or we could even double this if we want, but it doesn't matter, whatever you want to use. So we could use 6 centimeters here, and that means that we've got to use, if this is in a ratio of 3 to 2, the larger side has to be 9, because 9 to 6 in lowest terms is 3 to 2. So this still satisfies the original ratio of 3 to 2. So this is going to be centimeters as well. So now for part B, you have to determine the areas of each of the squares. Remember, we have to use the formula area equals length times width. So now go find the areas of each of these squares and compare the ratio of the largest to the smallest.